Hi there. What this is going to be is a quick example and brief discussion of why bottoms-up factoring works, so it hopefully doesn't just seem like some magical mathematical process. The example I've chosen is 5x squared minus 17x plus 6. Well, the first thing we're going to do is actually just do bottoms up on this. And in bottoms up, the first thing is I took the first number and multiplied it by the last. So I'm going to take this 5 and multiply it by 6 and get 30. And then I'm just going to recopy down this middle term. Again, it is negative 17. So my question then becomes, what two numbers add and get negative 17 and multiply and get 30? Well, those two numbers are negative 15 and negative 2. My next step in bottoms up was to take those numbers, negative 15 and negative 2, and divide by this coefficient associated with x squared. So I'm going to take them and divide by 5. So I'll have negative 15 over 5 and negative 2 over 5. Simplifying where I can, negative 15 over 5 becomes negative 3, and negative 2 over 5 just stays as negative 2 over 5. Continuing along, I'll have x minus 3 and x minus 2/5. Well, eventually I want it so where this isn't going to be a fraction over here, and the way that I did the last step was I went bottoms up. I look at this number on the bottom, the 5, I'm going to multiply this whole second term by 5 so that my initial expression will factor into x minus 3 times 5x minus 2. And that's my answer, and I found it using bottoms up. And the question then becomes, why does bottoms up work? What's really going on? Well, to begin to answer that question, the first step I'm going to do is I'm going to factor out a 5 from the expression. So I'll have 5x squared minus 17 fifths x plus 6 fifths. And the reason I've done this is because I've gotten it to an expression that we've worked with before, where this number in front of the x squared is a 1. So I can ask myself, what two numbers will add and give me negative 17 fifths and multiply and give me 6 fifths? Well, the problem is when you multiply a fifth times a fifth, you get a 25th. And to account for that, what we're going to do is we're going to write this 6 fifths at the end in terms of how many 25ths it truly is. And that's going to be 5x squared then, 17 fifths x, and 6 fifths in terms of 25ths is 30 25ths. So now I can ask, how many fifths do I need in order to add and get negative 17 and multiply and get this 30 25ths? And that's exactly what bottoms up was doing. And look, before I had this 5 and 6 were giving me the 30, and this negative 17 right here showed its head again. So I asked what two numbers are going to multiply and give me 30 and add and give me negative 17. And the only difference is now that we're thinking of them in terms of fifths. And before they were negative 15 and negative 2, and they're the same thing again, except they're just going to be, like I said, in terms of fifths. So my two numbers that are going to add and give me negative 17 fifths and multiply and give me 30 25ths, well, they're going to be my 2 fifths and my 15 fifths. Now what I'm going to do is I'm going to simplify where I can, and that's in this last term. And negative 15 over 5 is going to simplify into this negative 3. Now what I'm going to do is I'm going to actually distribute this 5 in this first term. Distributing the 5, I'll get my final answer of 5x minus 2 times x minus 3. And that's actually the same answer I found using bottoms up. So hopefully this kind of demystifies things and helps you out. Thank you very much.